Okay, what we're doing today is we're going to do our geometric, binomial, and normal model. Okay, so let's open up to that one. And so the first thing we have to do is know, that thing go away. There we go. Know what a Bernoulli trial is. And remember, Bernoulli trial is when things are, is it independent? It only has two possible outcomes. It's either success or failure. And the probability is constant. It doesn't change. And so like playing cards and taking the cards out of a deck and not returning them, the probability changes, so that won't work. And then when we do things, there was two types that we use in our calculator. There was either PDF for perfect and the exact amount, or CDF for cumulative. Okay, so then let's see what's next. So for geometric, there was, there's a couple different things we need to know. Geometric is when you're counting until you find your first success, where P is success, Q is failure, and X is when you get the first success. Right here, this one, this expected mean, this question is how many do you expect to see before getting your first? And so that one you have to recognize, okay, it's looking for the first and it says expected, so that's my mean. So be careful on that one. That one's kind of tricky to recognize. And then our formula is just the failures, how many failures you have, and then how many successes you have. And we've been doing things with blanks, and so like this is your first yes, and so then these are no's, however you want to do it. And then remember there's PDF if it's exactly, and there's CDF, which is cumulative. Okay, and the next thing we have is binomial models, and binomial models, they count how many successes. So for this one, the big thing is you have to know how many trials there are. So if you ever have anything with the number of trials, that's got to be binomial, okay? And X is still when you get your success. Okay, so EX, again, that's the mean. That's your expected value. That's the mean. That's just N times P, and your standard deviation is NPQ. We had been using the binomial PDF and CDF, but you might also see this notation, and this is just saying N choose 5, N choose however many. So N is how many trials, 5 is how many you have, and this should actually be not X minus 1, but N minus X. I got those wrong. So N minus X. So let's say we have our trials is 8, and we want to see up to 3. And so what it does is this is 8, choose 3, and it's your P to the 3, and your Q to the 8 minus 3, which is 5. So that's what those two notations mean. And for this, really, you just have to know how to find it, how to choose it multiple choice. You don't have to write it like this. You can write binomial or CDF or PDF and list your parameters, and you'll be good. Okay, then sometimes what happened is we would go to normal model, and we would go to normal model if I had at least 10 successes and at least 10 failures. And so if you go to normal model, your mean is this N times P, so how many successes, the success percent times how many are in the trials, and your standard deviation is this. And then from here, you use normal CDF. And then the last thing, remember, when we want the number of successes are at least 1, it's 1 minus what you don't want. And so at least is 1 minus what you don't want, right? And so if I want more than 3 successes, then that means 1 minus up to 2, because 3 is the higher. And so we would do binomial CDF up to there. Okay. So remember, Bernoulli trial has to meet those 3 conditions, and then you identify, okay, is it a binomial or geometric? Geometric looks for the first success. Binomial finds the percent of that many successes happening.